This video will show you how to use Microsoft Excel to create graphs and then use those graphs to determine some equations of the lines and some basic statistics surrounding some of the coefficients that it retrieves. First thing we see is I've got a ramp set up, a fictitious experiment where a ball is dropping down the ramp, and at every 1 meter I've drawn a little blue dash. And what we do is we have a stopwatch out. We can imagine we've got a stopwatch, and we record how long it takes for the ball to pass the 1 meter mark, then the 2 meter, all the way down to the 8 meter mark. And these are the values that we obtain in this little table. So the first thing we want to do is take this table and put it into Excel. So let's do that. So I've entered my data into an Excel spreadsheet. You can see time in column A and position in column B. Now, Excel automatically assigns the leftmost column to the x-axis and the rightmost column to the y-axis when you're selecting data. If you have them backwards, there is ways to swap the data. We'll look at that in some later tutorial. But for now, we want to graph on the x-axis time and on the y-axis position. So what we want to do is select our data and go to Insert. And we want to find the appropriate chart, which is a scatter plot. So we're going to pick scatter plot A, and we're going to now see if we can get some titles and various features on it. So we can see Excel has made us a nice scatter plot graph, but the titles are a little bit off. Now we want the titles to read position versus time at the top, and then we want to label the x and y axis. So to do that, click on the little plus sign and go to axis titles, and they automatically appear. So notice the one on the y-axis is selected. Let's enter the actual axis title. I can also make it a little bit bigger. Same thing on the x-axis. Just click on axis title. That should read time, and we want time in seconds. Good to go. And the same thing at the top. We want position versus time. Next, what we want to do is fit our curve to a... Now let's use Excel to fit the curve. Put your mouse on the graph and select one of the points, then right-click and go down to Add Trend Line. And when you do that, you'll see a list on the right appearing, and right now it's saying linear, which is a straight line. We clearly have a curve here, so we're going to pick polynomial of order 2, and notice it automatically curved it up. Order 2 just means it's a square function or a quadratic, and then once we're satisfied with it, we just hit OK. Once we're satisfied that our curve fits the data, we go down to the bottom where it says Format Trend Line and hit Display Equation on Chart. And Excel will automatically put the equation right on your graph. So for the equation for this line is y is 2.5837x squared minus 0.1134x plus 0.0217, a quadratic equation. Now that we know that our equation fits a quadratic, we're in a position to straighten out the line. So we're going to use Excel to do this. So let's turn off our Format Trend Line. Let's move our graph over. We're going to create a new column called time squared. And the units for that column will simply be seconds squared. Now I want to see the title, so I'm going to slide it over. There's my time squared column. Let's make it a little bit bigger so we can actually see what we're doing. And we're good to go. Now in Excel, whenever you want to do an equation, we want to take the time column and square it. You always start with an equal sign. So I go equals, and I want to grab cell A2, and I want to square it. So I just raise it to the power of 2 and hit enter. 0 squared, of course, is 0. Now I want to copy that cell and paste it below. So right-click, copy, and then paste into these cells here. Right-click, and I want to paste the first option, And it doesn't hurt to check to make sure it's actually right. Is 0.62 squared the same thing as 0.3844? And if you look at your calculator, that is in fact the case. And again, I'm just going to make this a little bit bigger so we can see it. And there's all our time squared data. So now we're in a position to regraph. We want time squared on the x-axis and position on the y. Okay, so once again we'll select the data that we want to graph. So I'm going to select columns B and C, just the data. Remember, the first column, the leftmost column, will be on our x-axis, and then the rightmost column will be by default on the y. We're going to want to switch those eventually. But we've selected the data for now. Let's get a graph. So insert, chart, scatter. Let's add some titles, axis titles. Now remember, we want to swap the axis so that our x-axis is time squared and our y-axis is position. So to swap the axes, just right-click on one of the data points, select data, and let's edit series 1. So first of all, wipe off spreadsheet values that are currently there. We want the y value to be position, so let's click here. There's position. And I want my x value to be t squared. Should be good to go. So notice now my x-axis has the right increments and my y-axis as well as the right increments. Now we can add our titles. So now let's get the equation of our straight line. Again, we'll select a point, right-click, add trend line. It's clearly a linear function. Let's display the equation on the chart, and we are good to go. So the equation of this line is y is 2.5269x minus 0.0176, and we'll talk about that equation in the lab. Now I want to get some error surrounding those numbers. So we're going to do a regression. And to do a regression, you go to your data, go to data analysis, down to regression, hit OK. Our y range is going to be our position data, so it looks like it's OK. And our x range is going to be our time squared in fact. So we've got to make sure we flick that one around to column C. Hit OK, and there's all the statistics we could ever want. All we've got to do is discuss them. So we'll just expand some of these columns so we can see what they are. And here we've got data surrounding my x-intercept. The x-intercept is given once again, and also the coefficient in front of the x, which we know is the slope, right? Y is mx plus b, so that coefficient would be the slope. This represents the error in the slope, so these two are tied to each other. So my slope is 2.52 plus or minus 0.03. My intercept is negative 0.0175 plus or minus 0.05. Notice the error is bigger than the actual coefficient for the intercept, which suggests to me that the intercept should be 0. But interpretation is always up to the scientist. So for now, let's focus on the slope. My slope has a value of 2.53 if I round off, with a standard error of plus or minus 0.03. And that's going to be very useful when we do our error analysis later on. So those are the columns you want to focus on. So according to Excel, the equation of our straight line for the graph of d versus t squared is y is mx plus b, where the slope was 2.5269. The intercept was negative 0.176, and when we did our regression statistics on it, we found that the slope had an error of plus or minus 0.03, and the intercept had an error of plus or minus 0.06. Remember, standard errors you should generally round off to just one significant figure, and then the unit that's associated with it should also have the same number of decimal places. So our best equation for the graph would look like this. Y is 2.53 plus or minus 0.03 x minus negative 0.02 plus or minus 0.06. And the rest is all up to you to interpret. You have to be able to interpret the slope, including the error, as well as the intercept. Good luck.